Welcome back, everybody, for day 4 of the AWS Certified Developer Bootcamp. Let me know when you see the feed. Let me know we're live.
There you go. It's on.
We're good?
Live.
Cool. All right. So, I wanted to open up the floor to any questions that anybody might have before we jump into the next topic, which is Elastic Beanstalk. Yes?
A quick one about the throughput thing. So, it sends you a good message if you exceed the throughput.
Mm-hmm.
How is that like averaged? So normally your usage, like on a web page or a website or whatever, would be up and down. So if you buy so many reads per second, do you see where I'm going with this? Like, if you exceed it for 1 second, but then the next second you do no reads, is it going to block the first second and then?
So you're asking on a dynamo table with throughput, how is your exception handled based on the throughput at the time, because there may be fluctuations in your application? Is that?
Well, that, and how do you determine your throughput over time? So over, normally you're not writing 10 objects a second. You might write 100 objects 1 second, and then write nothing for 5 seconds, and then write 15 objects for a second.
Okay, so based on demand, your read and write would be changing consistently. Is kind of what you're getting at?
Or maybe even inconsistently.
Well, okay. It's changing. How much it's changing, we don't know, but it is changing in a manner that we can't exactly account for.
Right.
Okay. I've not encountered this myself, so I'm going to say from what I know and kind of go from there. When you make a put or a get from Dynamo, these are API calls. It is my understanding that when you get that message, it is in response to that API call. So if you exceeded your throughput for a time, I would expect that those API calls would receive that message. But once you go back below your threshold limits, I don't expect that you would see those errors on the records under the threshold limits.
Okay.
Does that make sense?
Yeah.
Okay. Like I said, this is an area that I'm getting my feet wet in. I don't have a lot of experience in Dynamo, but it's something I'm learning as well. But that's a good question. Is that at least a somewhat satisfactory answer?
Yeah.
Okay. Okay. Any other questions? Okay. Then we're going to jump into a service called Elastic Beanstalk. And we're going to try to make videos work again today. So, bear with me. What is Elastic Beanstalk?
The frustrating job of the accidental sysadmin. As a developer, you just want to build a great website or mobile app, but somehow always end up as a system administrator. You spend a lot of time managing and configuring servers, databases, load balancers, firewalls, and networks instead of coding. Whenever you have to scale your servers to support more users, it becomes a headache because of the extra time you spend re-architecting your infrastructure. Wouldn't it be nice if you could just focus on writing code and building a great product and hand over the provisioning and scaling of the infrastructure and the installation and management of the application stack to someone else? Introducing AWS Elastic Beanstalk. Elastic Beanstalk is an easy-to-use service that deploys, manages, and scales web apps and services for you. Elastic Beanstalk uses managed containers that support environments such as Java, .NET, PHP, Node.js, Python, Ruby, and Docker on familiar servers such as Apache HTTP Server, Apache Tomcat, Nginx, Passenger, and IIS. Elastic Beanstalk leverages familiar AWS services such as Amazon EC2, S3, Simple Notification Service, Elastic Load Balancing, and Auto-Scaling. It's easy to get started on Elastic Beanstalk. You can use the AWS Management Console, the command line interface, or the API. You just choose your platform, like Node.js or Ruby, and Amazon EC2 instance type. Then, you select additional resources to use, such as Amazon Relational Database Service or Amazon Virtual Private Cloud, and then just upload your code. Elastic Beanstalk will handle the rest of the deployment details, such as provisioning, load balancing, auto-scaling, and application health monitoring. Elastic Beanstalk will automatically scale your application up and down based on easily adjustable auto-scaling settings. With Elastic Beanstalk, you also retain full control over all the AWS resources powering your app. You can take over some or all of the resources of your infrastructure anytime, so you're not forced to live with predetermined configurations. Elastic Beanstalk lets you focus on building great web or mobile apps for your users without spending a lot of time managing and configuring infrastructure. You can build things like websites, content management systems, API backends, and even SaaS applications. Elastic Beanstalk can help get you to market faster because it's quick and simple to get started. Elastic Beanstalk automatically load balances and manages scale, helping to make sure your app is always available. You can also tweak any Elastic Beanstalk resource you want when you need to, giving you complete control under the hood. Even better, there's no additional charge for Elastic Beanstalk. You pay only for the AWS resources needed to store and run your applications. To get started running your applications with AWS Elastic Beanstalk, visit our website and get your first app up and running with a few clicks in the AWS Management Console.
Okay. Alright, Elastic Beanstalk. It's a deployment tool allowing for the simple creation, update, and deployment of or to environments. So this is great for developers or people new to the cloud or cloud-based development environments. This is one of 3 deployment tools that Amazon has. The 2 that we cover for the developer exam are Beanstalk and CloudFormation, which we will get to later today. There's a third, OpsWorks, which uses Chef, if anybody's familiar with Chef. But that isn't hit until somewhat of the SysOps exam and the DevOps exam. So for the scope of the developer exam, we'll be talking about Beanstalk and CloudFormation. Beanstalk supports multiple tiers such as web, application, and database. And some of the supported applications you can have with a Beanstalk are Apache Tomcat for Java, Apache HTTP servers for PHP, Apache PHP servers for Python, Nginx or Apache HTTP servers for Node.js, Passenger or Puma for Ruby, Microsoft IIS for .NET, Java SE, Docker, or Go. So this is oftentimes used if somebody's new to the cloud, they want an application, they want to get it up and running fast, and may migrate over to a more verbose solution later down the road. But this is a great get your feet wet tool. We're not going to go really any further with this one. That's about the scope of what you need to know for the exam. Remember kind of what you can spin up with an Elastic Beanstalk and what is its basic purpose. Any questions? Okay. If there are no questions, then we are going to go to the next topic, which is SWF, Simple Workflow Service. Simple Workflow Service is a task-focused service that makes it easy to coordinate work across distributed applications, components, or human actors. Tasks are assigned once and only once. So let's put 2 services head to head against each other. Let's talk SWF versus SQS. SWF is task focused, where SQS is message focused. They both will provide messages down kind of a chain, but workflow is much more task oriented against a workflow itself. This is a tool that you could use. So let's go with the scenario. You might use SWF if you were Amazon and you wanted to fulfill orders that were placed on Amazon's website. So an order may come in, a request for an order, and then payment is accepted. These are tasks that happen within the workflow itself. Once the purchase has been made and the payment's been processed, it moves on to the next task, which may notify an employee in a warehouse to go and get that item. this is where the human interaction comes in. So let's talk about some of the components real quick with these. We have workers, which are programs to get processes or tasks and return a result. Domains, which are the scope of the workflow. And deciders, which are programs that control the coordination of tasks. So we may have a decider that says, which warehouse do I need to send this to? And it will determine which task flow to go down, and it will send the message down to a worker and says, worker, go and pick up this following item from the floor. Now the worker, which in this case would be like an Amazon employee or a fulfillment employee, would go into the warehouse, grab the item. Once they have it, they would notify the SWF workflow that they have that item, which now processes the task down the line. And it may then go into shipping, and they may package it and ship it, and then that task would be complete and then shipped. That might be the last task in that workflow. The longest task that you can have is 1 year. So remember that SWF is task focused, and its longest thing that it can do is 1 year. SQS, and let's go back a little bit to SQS, is message focused. And its longest retention is 14 days. So SWF might be for things, longer term projects, longer scope projects, in which you need to track one and only one time each task. So that each task is fulfilled only once. SQS can be delivered multiple times because an item could be taken from the queue, not fully fulfilled, and then reintroduced back into the queue after it gets fulfilled by another worker, and then that next worker will do the load as well. So if you need something that once and only once for SQS standard queues, it could happen more than once, but SWF is once and only once. Does that make sense? So make sure you know the difference between SWF, SNS, and SQS. Questions? No questions? Okay. Then we're going to jump into the next topic, and this is a big topic. This will be covered on every exam, every of the associate and professional exams, and I believe it's on most of the specialty exams as well. But it's VPC, Virtual Private Cloud. This is one of the underlying core components that makes Amazon as powerful as it is. So a Virtual Private Cloud, or VPC, is an Amazon's implementation of a virtual private data center in the cloud. So it's you creating kind of your own special network that's isolated to you in the cloud. All resources not explicitly associated to a VPC are created in a default VPC. So even when you're creating objects in in an Amazon AWS account and you have not specified a VPC, Amazon has already specified default VPCs. So everything is still created in a VPC, whether or not you have created that VPC or not. But all resources need to be in a VPC, whether it be the default or your own specified ones. So here are some of the components of VPC. We have subnets, and subnets are containers to hold resources for a specific availability zone. A single subnet can only span one availability zone. You cannot span multiple availability zones with a subnet. Make sure that you remember that. That is very important. Subnets can be public or private depending if they have a route to the internet gateway. Okay? So what is an internet gateway? We have two types of gateways we're going to talk about. An internet gateway, IGW, is an attachment that allows internet traffic into the VPC. So if you want your data center, your VPC, to have access to the internet, it must have an internet gateway attached to it. We also have virtual private gateways, or VPGs. These are an attachment that allow VPN traffic into a VPC. Now this is a hardware VPN. You are able to go over the internet and do a software VPN if you so chose. But if you wanted to attach a hardware VPN in which your on-premise environment would have a router or something for that VPN, you need a VPG to connect it to your virtual private cloud. Route tables. Route tables are tables that map where traffic is routed to and permitted. So, let's see. Route tables are what you would hook up to an internet gateway. So, internet gateway has traffic flowing in for the internet. It would be then routed to a route table. And that route table would then specify where that traffic is permitted. The route tables and their corresponding links are what provide either internet access for or not to subnets or resources. And we're going to go over an example. I know there's a lot here, but we're going to go over an example of this. Question?
Could you remind me real quick the difference between a region and an availability zone?
Okay, so in region, it is a location, and I'll actually read it. It's a geographical location that AWS hosts a data center, and then an availability zone is a data center within a specific region. So a region has multiple availability zones. So it's an area in which they said, we're going to create data centers in, and then the availability zones are the actual data centers that are in that region.
Okay.
Does that make sense?
I think so.
Other questions? Okay. Security. There are two ways in which we control security in a VPC. And these are through NACLs, Network Access Control Lists, and security groups. Make sure you know the difference on these. These are very important. So a network ACL is stateless, which means inbound and outbound responses, inbound and outbound traffic must be explicitly defined. You can define both allows and deny rules, and rules are ordered from lowest to highest and executed as soon as applicable rules found. All right, so we're going to switch over to the whiteboard, and let's kind of put all this stuff together so far, because I've thrown a ton of terminology at you, and let's break it down.
Can you check your microphone, make sure it's employed, because he's getting a lot of sound, like a fan sound, and not you can't barely hear you. If you don't see anything, then we'll just keep going. But
I'm not seeing any issues with it.
okay.
It should be working right.
Okay.
Okay. Can you see the camera, by the way?
Yes.
Okay. So, let's write a VPC. Our own little slice of Amazon. This is a VPC. It's just our container in which we want to house our resources and that we want to control those resources. Attached to a VPC, if we want traffic, we need an IGW, Internet Gateway. So now we have HTTP, HTTPS, etc. Internet traffic. This is its point of access into our VPC. We are going to have subnets. And if you guys want to follow along, at the end of your packet, we actually I have a VPC diagram in there for you. That's what I'm working off of. It may be helpful if you would label the items that are on your graph. And I know the people that are remote, I need to send a copy of this, so I apologize. I will, at the end of this meeting, send out a copy of the VPC diagram. Okay, so let's say that we have a Route 53. So that T looking thing, I'm not good at drawing, but this is a Route 53 entry. We have traffic coming from Route 53 into our internet gateway. That's a little cloud. Then we have subnets. This is our public subnet. Let's call it 1. Private subnet 1. And these are 1 because these are all in, let's call them A, not 1, because it'll make it a little easier to understand. A, because these are all part of availability zone A. Then we have another availability zone. This is for high availability. We have it in 2 different availability zones. So we have 2 different subnets because we can't span a subnet across multiple availability zones. We're going to have our public subnet B and private subnet B. Okay, so, and these are in their own availability zones. And that is A, Z, B. Okay, so what makes a subnet public or private? Well, what makes a subnet public or private is a route table that is attached to subnets. So the route table says once I have traffic, here is my mappings of where I'm going to route traffic to. Currently we have traffic coming in through our internet gateway, and it's coming down into our route table, and it is attached to subnets, public subnets A and B. So these are now public, which means that they get internet access because they have a route from this public route table. Does that make sense? These currently are not public because there is no route out of the VPC through the internet gateway. Now we will have private route tables that we can use to get traffic to different subnets. So these are permitting traffic from the private subnets into the publics. So anything that we would spin up in our privates, and items in the public could access them. But the outside internet cannot, because the route tables here are private. They do not have a route out to the internet gateway. Does that make sense? Okay. All right, so that's where we are so far, and we're going to talk about the network ACLs. I don't really want to erase that. All right, so let's come over here, and if I run out of board, let me know. Let's talk about NACL. Okay, so we've talked about how in a network ACL, there are rules, and how rules are evaluated in order of rule number. So, let me grab my notes. Let's say that we have a network access control list. And we've got a different color here. Network access control lists are at a subnet level. So I may want to control the traffic that can get into my subnets by a network access control list. So let's wrap my network access control list around these subnets. And I'm saying I'm going to either permit or deny traffic into these subnets for my network access control list, or by my network access control list. So I'm going to have rules, and let's say rule 100. That's going to be an allow rule for any, let me bring this closer because I'm probably going to run out of space on the screen. So rule number, port, allow, deny, and IP. So our network ACL, we'll say let's have a rule 100, and that is going to be on port 80. I'm going to allow traffic from my IP. So I'm stating that anything that's going to a network ACL that is going across port 80 with my IP, permit it through. Now I might have another rule here for 200, rule number 200 for 443, and I might want to deny 172.82.43.12. That's not a real IP address, but work with me. So this is if this IP along 443 came in through the internet gateway and hit here, it gets blocked. So think of the network ACL as the guard at the gate. And he's saying, do you have credentials to come in? And we're looking at our list here. Well, it's going to come first and it's going to check out rule 100. Does this apply? Nope. The IP is not right. The IP is different. Keep looking at my rules. Rule 200. Is it this guy? Yes, this is his identity. What am I supposed to, and which port is he coming in? Which door is he coming in? He's coming in 443. Is he allowed to come in through this door? No. That traffic would be blocked before it even reaches the subnet. Now, let's go rule 300. And let's say I have a rule for port 80, and I might accidentally put this in of my IP. Now I have a clash of rules. On rule 100 for port 80, I'm allowed. But on rule 300, I am on the same port, not allowed. Would I get through?
Yep. Yep.
The answer, a lot of people are saying no. I've heard a few, or I'm sorry, a lot of people are saying yes. But there's mixed results. And the answer is yes, I would still get through. Because as the guard here at the gate is looking, he says, rule 100, are you my IP? Yes. Are you trying to come in on port 80? Yes. You're allowed. I stop evaluating the rules from there. However, when we came in with 172, we skipped that because that wasn't the right IP. So once it finds a rule that applies, it stops looking. So if I switch these up, and I made this a deny, and this an allow, can I get in? No. Because it says, I found a rule that applies, you're not allowed. I'm not even going to look any further. Question?
Is there a rule about if there's multiple allows and denies that the denies win? What was that, a couple days ago?
Yeah,
That's on permissions.
That's permissions.
Oh, it doesn't apply here.
Correct, because these are rules and not permission. Like, you're managing your permission based on these rules. But it's because it's evaluated at the time it finds any answer. It doesn't look any further. For your network access control lists. So does everybody follow? Okay. Let's switch back over. So some of the components of a rule in a network ACL is the rule number, the type, the protocol, the range, the source, and whether it's allowed or denied. Any questions so far? Okay, security groups. These are the second type of security control within a VPC. You will use security groups quite often. So security groups are what we call stateful, which means inbound requests implicitly receive outbound permission. So let's contrast this. Actually, let me flip back over to our network ACL to explain the difference between these two. So this was, let's call this, these were inbound. So these rules all applied to inbound traffic only. Now I have an outbound list. And on my outbound, I might say, for rule 100, port 80, deny my IP. So let's change this back here. And let's say that I'm allowing myself in. So I'm allowing a request to go through the network ACL, okay, for my IP. So it comes in, and let's say that we have some EC2 servers in here. We're coming in, we're going to hit our route table. Route table says, okay, I see traffic. I'm going to send it over now over into my public subnet. Now this is actually done with an auto-scaling group, but that's what your diagrams have. But for this example, we're just going to say that we were routing to these EC2 specifically. Okay? So we get to the NACL and it says, are you permitted? Rule 180, allow my IP. Okay, I'm going to let you in. We reach the EC2s. Now, we're not talking about security groups yet, so ignore that component for now. They process what I'm doing. They send the response out. Guard's waiting on the other end going, is this allowed to go out? Rule 180, deny IP. I'm blocking you from sending this out. You made the request in, fine. I'm not letting your response back out. So the NACL watches both ways. And just because you have a rule letting it in, doesn't mean you have a rule letting it out. Does that make sense? Okay. Security groups. Security groups are stateful. So inbound requests implicitly receive outbound permission. In our example that we just talked about, the network ACLs, if I have an inbound rule for my IP that allows it in, I implicitly have an outbound rule that allows that out. So requests can go out with security groups, even if you don't specify a rule to make that happen. You can only define allow rules with security groups. So with network ACLs, you can define allow or deny. But with security groups, you can only write allow rules. All rules are evaluated independent of order. So in a network ACL, we said rule 100, rule 200, rule 300. I went in order. Security groups say, I'm going to evaluate them all. This is kind of where you're in, where you get into, it doesn't matter which order you're in. As long as you have, if you're permitted, you're permitted. And we can't have any denies. So there is no conflict between the allow-deny issue and a security group because they're only allows. So if any rule in my security group states that I'm in, then I'm in. Some components of a security group is the type, the protocol, the port range, the source, and a description. So switch over. Security groups. And I'm going to have a type and ports and source and description and some others I'm not going to put up there. So let's say I want to allow HTTP traffic, which is on port 80, through for my IP. That's stating that any HTTP traffic coming across port 80 for my IP is allowed in. So where we know that the network ACL exists outside the subnet, permitting traffic into our subnets, where do our security groups live? They live within our subnets. So in this case, our next line of defense is our security groups. So once we get in, then we need permissions to get in through the security groups. So you might have rules that permit traffic in for your network ACL, but you may not have whitelisted that traffic through your security group, so you still may not get into those instances. An example might be that my network ACL may allow all traffic to come in for port 80, but then I may only whitelist certain IPs in my security group to get to those EC2 instances. Does that make sense? So there's two levels of that we can manage security. Now we can only handle the security group that allows, and we can explicitly deny traffic even reaching our subnets through here. This is very effective and very powerful when you're trying to deal with things like mitigating DDoS attacks. If you know an IP that's having issues with people trying to DDoS you across it, you can explicitly deny it before it ever even reaches into your subnets. So that might be a place you'd want to deny rule. I'm blacklisting certain people. I'm not even going to let you in. But then when I get closer, I'm going to evaluate, because I may not want to write rules for every single IP through my subnet, but my security groups, because I could have different subnets, or sorry, different security groups for different resources. So maybe I have 2 groups of EC2s, and I then have 2 security groups. So I can use my network ACL to control kind of a wider band of control, and my security groups to fine-tune the level of control I want to specific resources. Does that make sense? Cool. Okay, so private subnet access. So, give me a second to take a drink. We talked about how in our private subnets, there is no access out to the internet, correct? Then there are times that we may need access for a resource. Let's say that I have an EC2 instance in my private subnet, and I need to patch it. I may not want outside traffic to come in. I may not want to service responses to the outside world, but I still need to patch my machine. Or I need to install something. I may need to install MySQL or some tool. But with zero internet access, can I do that? No. There are 2 ways that we can provide internet access or access into resources from the outside world into items or into resources in our private subnets. Those are bastion hosts, and those are network access translation, either gateway or instance, NATs. So bastion hosts. Let's switch over to the board. A bastion, let's say that I have an EC2 here, okay? This is some sort of worker utility that I have. But it is in a private subnet. It has no access out to the internet. And I need to do a yum update on my Linux instance. I need to update my instance here. Actually, sorry, let's flip back and let's do the bastion first. Let's say this is a Windows, because we're more familiar with Windows here. All right, this is a Windows EC2, and I need to run my Windows updates. I want to remote into this box, okay? But what is it? 338089 for RDP. I don't remember the exact port number, but either way, it is traffic that comes through the internet, and we remote into a box. So we want to remote into here, but we can't get to here because of this. So we're going to create an EC2 called a bastion here. And it's not a special type, it's just an EC2 instance that we spin up for the sole purpose of having access to jump in here. So I create another Windows EC2 instance. I'm sad because I can't get in. I'm going to go into here. I'm going to remote into here. And then from this box, I then am going to remote into here, which I can do, which makes me happy. So now I'm jumping, and from what I understand in Australia, they call these jump boxes, which is kind of helpful to remember. A bastion is just an instance that you use to jump into resources in your private subnet. One of the benefits of this is that instead of having to harden all your instances, so if we were to make routes here, which we don't want to do, to our public, we would have to harden or make sure that all of our EC2s are secured because they now could receive attacks from the internet. When there's no access from the internet into them, we have to be less worried about having external attacks come. So instead of having a bunch of EC2s here that we have to manage security and be worried about, we can harden one. I can make sure this is okay. I can make sure that I'm doing all my patching, that I'm doing all my, I may put third-party security tools on this to make sure that this box is okay. But now I don't have to manage a bunch of other EC2 instances and worry about the security on them. I worry about it here, and these don't even have access to the internet. Does that make sense? Okay. That is a bastion. Now NAT. Let's talk NAT instances first. Okay, let's take a look at what a NAT is. Okay, so a NAT instance is an EC2 instance placed in a public subnet that are used to permit internet traffic from resources in private subnets to reach external resources. A user must manage scaling, health, and patching of this instance. So, what that means is I'm going to place an EC2 instance in here, very similar to what we do with a bastion. Okay? But I'm using this kind of like a proxy. I'm just going to use this as pass-through for instances here. So I have my EC2 down here. I may initiate a request for an update, which is through my route table, and I know I'm drawing it here, but it goes in through this route table, gets access to this public subnet, and then through that gets to access to your NAT, and then the NAT carries that traffic through the public route table out through the internet gateway, and then we'll get a response, and it will come back through. Hit the NAT, NAT will then route it to what asked for it originally. However, the NAT may allow traffic responses back. It does not allow requests placed from outside to items or resources in a private subnet. So I could not ask to get to here and go through the NAT to get it. If I initiated that request, I cannot do that. The NAT will block it. It says, no, I'm not going to permit that through. So I can secure this NAT, and it does not permit requests to these machines, only responses to these machines. So we are securing them based on the traffic routing of the NAT. Does that make sense? Now, since we have a NAT instance, we need to maintain that it is patched. We need to make sure that the instance is healthy. We need to make sure that we're maintaining them. So one little trick that's used with these, because what might happen is if I have resources down here and my EC2 goes bad and it fails and it crashes and I have an outage, my NAT's down, that means all my resources in here don't have access. Some people will put these under autoscalers. It's called self-healing. So when it detects that it goes unhealthy, it will then spin up a new instance so that you're not down and out. Does that make sense? Another very important thing to remember about NAT instances is that there is a setting called source checking. Let me make sure I'm saying that correctly. I don't have it on here. But there is a source check, source and destination check on your EC2 instance that you must disable for this to work. So what this does is if you don't have that, it recognizes that this is not the final endpoint and will block that. If you want this to be pretty much a pass-through agent, which is what you're trying to make this, then you need to disable the check that it's either the source or destination. Does that make sense? Okay. Now, NATs, you have to manage them yourselves, kind of a pain. Amazon recognized this and said, let's make a managed service for that. Let's make a NAT gateway. So this is a managed version of a NAT. It is an appliance in which you deploy, a resource you deploy into your public subnets, and they worry about the patching, they worry about the scaling, they worry about the health. It acts the same way. You don't need to disable the checking. Its sole purpose is routing traffic requests and responses from the private subnets. Does that make sense? Gateways are moderately new. It was done by NAT instances for a long time, and they provided a simpler way to do it. So with your NAT gateways, it's similar to your instance, except managed by AWS. AWS handles patching, scaling, and health. Questions so far? Okay. VPC peering. So what is VPC peering? And I'm actually going to erase that here in a second. We're going to talk about it. So VPC peering is direct network routing between two VPCs in the same region using public IPs. VPCs can be in different AWS accounts, but they must be in the same region. And they communicate as if they were in the same network. You cannot use VPC peering as a link to another VPC. So no transitive peering. So let's switch over to the whiteboard and let's break this down. What does this mean? All right, so you may have times where you need items in different VPCs and potentially even different accounts to talk to each other. We need a way to do that. So let's say I have a VPC here. Okay? And let's call this VPC A. I have VPC B and VPC C. If I have items that need access to resources here in A, I can get accesses via the private IPs by peering these together. Now, let's say that these are all in region US East 1. Okay? They have to be in the same region for this to work. But this may be in a different account. So let's just, where are the markers? So this is in account 1, and this might even be in account 1. That's fine. And this is in account 2. Doesn't matter, as long as they're in the same region. We establish a peering connections, which says I'm going to permit traffic between items in B and items in A. Now, they must not have conflicting CIDR blocks. So the private subnets, the mass subnets cannot be the same. So it might be, this might be 10.0.0.1, 10.0.0.2. So these are our masked subnets. I think I added a link in the resources section about CIDR blocks. If not, please look them up. They are important to understand. They're a little outside of the scope of what we're going to be talking about here. So now, with this peer, we have access to maybe, let's say that we have instances that are checking for security in A, and we want to route traffic and get some traffic analyzed in A to make sure it's not a threat before we route it to things in B. This link is now established. We can do that. But now let's say that we have a peering link between B and C. Now this permits, and then it's 10.0.0.3. Okay, now items in C and B, they can talk with each other. Can I get items in C to talk to items in A? No, because that is transitive peering. That's using B as a pass-through to get to A. If I want items in C to be able to talk to items in A, I need to establish a peering link between A and C. Does that make sense? Questions? Okay, we've got about 5 minutes left, and that's the end.
Are they the default VPCs?
I'm sorry, what?
Are these the default VPCs or the ones that?
So the question is, are these the default VPCs? No, these would be VPCs that we created because we're managing the CIDR blocks and the private IP ranges within them. So these would be VPCs for something that we would create.
So
And then,
can we peer to the default VPC, ours to the default as well?
I don't know. So the question was, can you peer your default VPC with your own VPC? I don't know, honestly. If they have different private IP ranges, they should work. I don't know of any reason that would block those, but I've never tried it.
I'm kind of doubtful on that, just because the default VPC is what we used to think of as our account, and so they assign internal private IPs. So I would guess that wouldn't be allowed.
And that may be true. What we can control though is the public IP ranges or the private IP ranges that we assign, and if the ones we assign were not in conflict. Like I said, I don't know. I've never tried that. It's a good question. Any other questions? Okay, I don't really want to jump into CloudFormation or any of the other topics just yet then. So I guess we will cover CloudFormation and the remainder tomorrow. So unless there are any questions, yes, question.
My question is with the network access control list.
Okay.
Is that one per VPC, or where's that? Because you said that you can have multiple security groups in a subnet. I'm just curious about the network access control list.
Okay, so the question was, can you only have one network access control list within a VPC? No, you can have multiples, and it's a one-to-many, and I got to see if I can remember this correctly. You can have a network access control list pointing to multiple subnets, but subnets can only have one network access control list.
Okay.
Does that make sense?
Yes. So the same NAC list can be used for all of your subnets in your
If you wanted, yes.
If you wanted to.
You
Okay,
could
great.
establish different ones if you wanted as well, but each subnet can only have one, but one can serve as many.
Okay.
Other questions? Okay, I know that was a lot to throw at you guys. Chew on it, digest it. VPC is covered very heavily in all of the exams. So this is an extremely important topic to understand. So if there are no further questions, have a good day.
Thank you.
Thank you.